Hello students, today I will discuss application of calculus in physics. This is part 4. Previously 3 times I have discussed on this topic. So here now F is equal to ma, you know. Force is equal to mass into acceleration. Force is equal to mass into acceleration. From Newton's second law of motion we can derive it. So I have written F is equal to ma, force F, m mass, a acceleration. Now m acceleration is the rate of change of velocity, therefore I can represent it as dv dt. Now v can be represented as dx dt. So v is equal to dx dt, and when we are doing dv dt, that is ddt of dx dt. That is, we can write as d2x dt2. So v is equal to dx dt, a is equal to dv dt, and v again is dx dt. Therefore I can write as ddt of dx dt, that is d2x dt2. So acceleration can be written as d2x dt2, and here I have written m is equal to dv dt is equal to m into d2x dt2. So F has this form, either ma or m is m dv dt or m d2x dt2. Now from Newton's second law of motion we know that rate of change of momentum is directly proportional to the applied force, from which we derive also that F is equal to rate of change of momentum. Actually there is a constant, and the constant becomes 1 when we define the definition of when we define the unit of force. That time mass is equal to 1, acceleration is equal to 1, therefore k, the constant, becomes also 1. Therefore we can say F is equal to dp dt. F means force, dp dt means rate of change of momentum. Now ddt of mv, momentum is mv, and m is taken out of the differentiation, so it is m into dv dt, that is ma. So I can say here F is equal to dp dt is equal to ddt of mv is equal to m dv dt is equal to ma is equal to m dv dt is equal to m d2x dt2. These are very small things, but if you connect all these relations all together, then it will be quite helpful for you when you will do the numericals. Next is impulse. Another idea I will explain. Suppose a batsman has hit a ball and struck a ball with the help of his bat, and that force is F, and the time is a small time interval, that is delta t. So F into delta t, that is called impulse. That is, generally when a large force acts on a body for a small time, we call that impulse. Okay, so I is equal to impulse, I is equal to F dt, integration t1 to t2, and F integration of dt that I have taken as delta 2 minus is integration of t2 under limit t1 to t2, so it will be t2 minus t1, and it is delta t. So I is equal to F into delta t, that is I is equal to force into small interval of time. Now I is equal to F delta t is equal to ma, mass into acceleration, force is mass into acceleration, into delta t, and m, a is delta v by delta t, and here delta t cancelled, therefore it is m delta v. I is equal to m delta v, and what is that? That is delta p, that is change in momentum. So impulse can be regarded as change in momentum. So from here we got the idea of F with so many differential form of F. Number 1. Number 2, the idea of impulse, and also impulse in differential terms. And here I have drawn the graph. If this is delta t and this is F is along the y-axis, delta t along the x-axis, then I impulse is equal to F into delta t. This rectangular portion shows the impulse. Because this is a rectangle length into breadth, you know that is the impulse. Hope you have understood. Try to subscribe my channel and give like wherever is possible. Thank you.